8.2, solving systems of equation by elimination. So it's standard MA 912, AR 9.6 again. So we want to solve systems of linear equations algebraically using the method of elimination. We want to solve the systems with no solutions or infinitely many solutions. Use the method of elimination to solve application problems. So the method of elimination says, step 1, you're going to obtain opposite coefficients of x or y by multiplying all terms of one or both equations by suitable constants. At step 2 is you're going to add the equations to eliminate one variable and solve the resulting equation. Step 3, substitute the solution from step 2 into either of the original equations and solve for the other variable. So in example 1, this is going to represent examples 1 through 3. It says solve the system of linear equations. They told us 5x plus 3y equal to 6, 2x minus 4y equal to 5. When you come to problems like this, look first for a plus minus situation. So there's a plus minus situation here. All the coefficients are different. So plus and minus situation here, I want to get 3 times 4 is 12, so I need to make these become a positive 12 and a negative 12, which means you are multiplying the first one by 4 and you're multiplying the second one by 3. So you're going to say 4 times 5, there's your 20x. 4 times 3, that's my 12y. 4 times 6, that is your 24. Then you're going to multiply the second one by 3. So 3 times your 2, that's your 6x. 3 times negative 4, it's a negative 12y. 3 times 5, that is your 15. So step 1 is you pick which of the two you want to change, if you have to change both or not. So in this instance we did. Match the y values, and this one I got rid of the y's, so when I go and add straight down, the y's cancel out. So 20 plus a 6, that's 26x. 24 plus 15, that is 39. And then you're dividing both sides by 26. So you get x equals 39 over 26. See if you can reduce it. If not, 39 is 3 and 13. 26 is 2 times 13. So the 13s cancel out, leaving you with 3 over 2 for the x component. Once you find x, you pick one of your two equations to replace x with. So then I did is look at the coefficients. This is a 5 times a fraction, which cannot be reduced easily. This is 2 times the fraction, which they have the same coefficient and denominator value. So I'm going to use the second equation and say 2x minus 4y equals 5. I'm substituting for x. I'm going to write 3 over 2 minus 4y equal to 5. The 2's are canceling, and you get 3 minus 4y equals 5. Subtract 3 over. So we have negative 4y equals 5 minus 3, that is a 2. Divide by negative 4 to both sides. So y equals 2 and negative 4 reduces to negative 1 over 2. So our ordered pair is 3 over 2, comma, negative 1 over 2, your x comma y situation. Example 4 says solve the system of linear equations. When I look at our problems, we are using decimals. It says 0.02x minus 0.05y equals negative 0.38. The second one says 0.03x plus 0.04y equals 1.04. I look at the unit number of decimal places. Each of my decimal places have 2 decimal places. So I am multiplying first every single one by 100 so I can get rid of my decimals. So I become 2x minus 5y equals negative 38. The second equation becomes 3x plus 4y equals 104. Whole numbers are a lot easier to work with instead of decimals, so this is why I did this. So then I look for a plus minus situation. A negative 5, positive 4. There's a plus minus right here. So I'm going to again get rid of my y's. I am multiplying the first equation by a 4 value to get to 20, negative 20. The second one by a positive 5 to get to positive 20. So 4 times 2, that is 8x. 4 times negative 5, that's negative 20y. 4 times negative 38. Gives us 152. So it's going to be equaling negative 152. You're going to do the second one. 5 times 3, that is my 15x. 5 times the 4, that's positive 20y. And then 5 times 104, that is going to be your 114, I believe. 520. So we have 520 on that instance. Remember what I said, you're going to add straight down. There's my plus minus situation with negative and positive 20. They cancel out. 8 plus 15, that is 23 with an x. Then you're going to do 520 minus the 152. And you get 368. So we get, and then divide both sides by 23. So x equals 16. So this one came out to be a whole number. So we have a 16 for our x position. Now, my suggestion is don't go back into the original decimal place values. Just pick one of those modified equation pieces. So I'm going to pick the first one. So I'm going to use 2x minus 5y equal to negative 38. And I'm going to substitute in 16 for x. 2 times my 16 minus 5y equals negative 38. So 2 times 16 is 32, minus 5y equals negative 38. We are subtracting 32 over. So you get negative 5y equals negative 38 and negative 32. They're both negative, so I'm still going to be negative. 38 plus 32, that is a 70. And then divide both sides by negative 5. So x equals, well, 70 divided by 5 is 14. So our solution point is 14 comma 16. Okay, so example 5, the no solution cases. It says solve the system of linear equations. It says 2x minus 6y equal to 5, 3x minus 9y equal to 2. So on this situation, find something that can easily be changed. See, both of these are negative. So you have an option of changing both of these to match, but 6 times 9 is 54, but 2 times 3 is 6. So I would change the x's to get rid of. You're going to multiply the first one. So it's plus and plus, and we make one minus. So I'm going to multiply the first one by 3, the second one by negative 2. So I get 3 times 2, that's 6x. 3 times negative 6, that's negative 18y. Equals 3 times 5, that is 15. Now I'm multiplying by negative 2. Negative 2 times 3, that's my negative 6x. Negative 2 times negative 9, that is positive 18y. Negative 2 times 2 is a negative 4. Remember, you're adding straight down. So 6x and negative 6x cancels, giving you 0. Negative 18x and positive 18x cancels, giving you 0. 15 minus 4 is a 11. 0 cannot equal 11. So this is why it's a no solution. Example 6, many solutions cases. It says solve the system of linear equations. They tell us 2x minus 6y equal to negative 5, negative 4x plus 12y equal to 10. I see a plus minus situation right here in the beginning, positive 2 and negative 4. If I multiply the top one by 2, I get a positive 2, positive 4 value. So I'm only using the top line. 2 times the 2, that is 4x. 2 times the negative 6, negative 12y. 2 times the negative 5, negative 10. And the second one's just going to slide over. I'm not changing it. When we add 4x and negative 4x cancels, giving you 0. Negative 12y and positive 12y cancels, giving you a 0. Negative 10 and positive 10 cancels, giving you a 0. You get 0 equals 0. This is called infinitely many solutions. Okay, example 7, a mixture problem. It says a company with 2 stores buys 6 large delivery vans and 5 small delivery vans. The first store receives 4 of the large vans and 2 of the small vans for a total cost of $200,000. The second store receives 2 of the large vans and 3 of the small vans for a total cost of $160,000. What is the cost of each type of van? So first thing we need to do is come up with a verbal model. So remember they said they delivered 6 large vehicle vans and 5 small. The first store had 4 large, so 4 times my cost of a large van, plus 2 of the small vans, equals, and they said it was $200,000. The second one said the second store received 2 of the large plus 3 of the small and paid $160,000. So we need to come up with labels. So we have a large van. I'm gonna make that X. We have a small van. I'm gonna use the variable Y. It's your choice. So we're gonna come up with 2 equations. It says 4 times the large, so 4x, because that's what X represents, plus 2 times the Y equals 200,000. The second one is gonna be 2x plus 3y equals 160,000. So we have 2 equations, 2 unknowns. When I notice here, I can make that x go away by multiplying the bottom by -2. So we are going to take the second equation and multiply by 2. So my first equation slides down. So I just rewrote the first equation. The second equation I'm multiplying by 2, and we become, by -2, and become -4x. -2 and 3 is -6y. And then 160,000 times -2, that's -320,000. When we add straight down, the x's are going to cancel. Had $2, but spent 6, I'm -4y. Then it's 200,000 minus the 320,000 is -120,000. So we're at that point. Example 8, it's a mixture problem. It says a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $732. In a second purchase at the same prices, the contractor pays $194 for 8 bundles of shingles and 1 roll of roofing paper. Find the price per bundle of shingles and the price per roll of roofing paper. So what we need to do is create a verbal model. So the first thing it says 30 bundles. So I'm gonna write 30 times the bundles of shingles plus 4 rolls of the roofing paper. So 4 times my rolls of roofing paper totaled $732. Then it says the second purchase, same prices, the contractor paid $194 for 8 bundles, so 8 times the bundles of shingles, plus 1 roll of paper, so 1 times the roll of paper, equal to 194. So we have our verbal description. So then we need to come up with labels. So I'm gonna say that the bundles of shingles is gonna be the letter X. The roofing paper is gonna be the letter Y. So we have our 2 setups. So bundle of shingles is X, so I'm gonna write 30X plus, it says roofing paper is the Y, so 4Y equals 732. The second one says 8 times the bundles of shingles, so I'm gonna write 8X plus 1 roll of paper, that's my Y, equals 194. So we have our 2 equations, 2 unknowns. To find out the price of the bundles of shingles and papers, we need to take one of our equations, which would be the second one, and solve for it. So I'm gonna rewrite this one by subtracting the 8X over. So it become Y equals negative 8X plus 194. That's what I'm gonna use for substitution purposes. I'm gonna take the first equation, which is 30X plus 4Y equals 732. And I'm gonna substitute in for Y. So we have 30X plus 4 times negative 8X plus 194 equals 732. So then we're going to distribute. So we have 30X. 4 times negative 8, it's negative 32 with an X. 4 times 194, so it's 776. 776 equals 732. You're going to combine like terms. So 30X and negative 32X is negative 2X. You're going to subtract your 776 over. So you get negative 2X equals 776 minus my 732. It's going to give us a negative 44. You have 2 negatives, that's fine. So when you divide 2 negatives by a negative, 2 negatives are being canceled out, so you become positive 22. So 22 is the cost of a bundle of shingles. They want to know the cost of a paper roll. So you have to take one of your equations. I would suggest the second equation. So 8X plus Y equals 194. We already know what X is. It is 22. So you have 8 times 22. It's 176. And then subtract the 176 over. So we get Y equals 18, which is the cost of the roll of paper. On example 9, it says break-even analysis. It says a small business invests $14,000 to produce a new energy bar. Each bar costs 80 cents to produce and sells for $1.50. How many bars must be sold before the business breaks even? So for this one, we need to find a verbal model. Remember, it's saying how many bars must be sold before it breaks even. So you need to use total cost is equal to the cost per bar times the number of bars plus your initial cost. And then the next one, because it's talking about revenue, we have total revenue is going to be equal to the price per bar times the number of bars. So now we need to come up with our labels. So we have our verbal models as to how we're gonna go about it, but we need to come up with some labels. So total cost is gonna be C. Cost per bar. They told us in the description, it's 80 cents. It says each bar costs, so that's our 80 cents. Then the number of bars is our unknown, so I'm gonna label that X. The initial cost, they told us it was invest $14,000, so that is your initial cost. Your total revenue, we don't know what that is, so that's gonna be our R. And then the price per bar, what we're selling it for. They told us that we're gonna be selling it for $1.50. So we have our unit pieces. Now let's come up with our two equations. So the first equation said total cost. So we have C equals cost per bar. The bars cost 80 cents. So I'm gonna put 0.80. The number of bars, we don't know, that's gonna be X, plus the initial cost. The initial cost is what we paid to invest, which was $14,000. The second equation says total revenue. So that's gonna be our R. And it says the price per bar, well, that's $1.50. And then number of bars, we don't know, that's gonna be X. So we have our two equations. So the question says, how many bars must be sold before the business breaks even? When it breaks even means when revenue is equivalent to cost, when the revenue equals the cost amount, that is when you break even. So we are setting up our two equations. So I'm gonna write revenue equal to cost. Our revenue equation is $1.50 with an X. Our cost equation is the 0.80X plus 14,000. So now we're solving for X. So I'm gonna subtract the 80 cents back. So you're getting 70 cents X equals 14,000. And then you're gonna divide by 70 cents. So we have 14,000 divided by 0.70 gives us 20,000. So X equals 20,000. So we need to sell 20,000 bars to break even.